Good afternoon to everybody. Today I am going to demonstrate you how to use our spectrometer for doing the absorbance transmission measurement. For doing the absorbance transmission measurement, you need some basic items. We need our spectrometers, light source, and the sample holders and some fibers. So first I will let you know how to do the proper connection of each and every series to get the results. So this is our light source. For connection of our light source, you have to put the power cable backside, and that will convert to the power socket. Step 1. Then for a spectrometer, you have to connect the one end of USB cable here and other end of USB cable to laptop. So I am just going to be connecting the laptop. Third, the spectrometer is TC cool, which is make the detector cool to -35°C. So for that, we have to put here cooling adapter. So once you put the cooling adapter, everything, then we make the power supply on. So I made it on. So now this electrical connection is okay. After that, for doing the measurement, we have to make some basic setups. As we going to do the absorbance measurement or transmission measurement, it means from one side I have to give the light, and from other side we have to connect the data from the sample. So one end of fiber I will connect to the light source. Other end I will connect this cuvette holder input port. Similarly, from other fiber I will connect one into the sample holder, other into the spectrometer. So this is the connection for doing absorption. In this sample holder, you can put 10 mm path length cuvette. So this is the camera. You have to insert like this one, or you can put any thin film like this. You can put the thin film. So this is the setup for doing the absorption measurement. Now I will let you know step by step how to do the measurement. So for doing the measurement, I am coming toward the software. I have opening the software. So just we open the software. Once the spectrometer is detected to the system, the run button is going to be enabled. So here you get here the run button is enabled. When I click on the run, it will start taking the spectra. When I uncheck the run button, it stops taking spectra. This is to change the exposure value of the system. Exposure value is, we can say as a thumb rule. If the single intensity is high, you have to decrease the exposure time. If the single intensity is low, you have to increase the exposure time. This is the boxcar. Boxcar is actually meant for smoothing the graph. Suppose I fill here boxcar value 2. It means it averaging the pixels n+1, n+2, n-1, n-2, and then giving you the spectrum. The third option that you have to check on the average, then how many spectra you want to average to get the final result. Suppose I say I want to do 10. The averaging will increase the signal to noise ratio. So that's why it will recommend that you do some average 5 or 10 so that you get better result. Now here you are getting that absorbance button is disabled and T button is disabled. The reason behind this is very simple. I will let you know. When we do the absorbance measurement is itself not a complete measurement. We are doing it on reference of something. So if I go to the formula of absorbance, the formula of absorbance is negative of log base to 10 I minus T divided by I0 minus T, where I is the sampling spectrum, I0 is the reference spectrum, and D is the noise, the background. Sorry. So to enable this button, we have to give these data to the software. So giving this data to the software is very simple. For this, first we have to make the light switch off on the light source. This light source is on here now. Once the light source is on, if you're working on the deuterium mode also, after taking it on, we have to wait for little bit time so that its deuterium lamp going to be ignite. Once it is ready, light is coming from here. in this portion or here, whatever reference you have compared to which you want to measure absorbance, you have to put over here. For example, here I am taking the blank cuvette as reference, so I will put here blank cuvette. After blank cuvette, I will adjust the cuvette. I will adjust exposure time. So we have to adjust the value of this one by varying the exposure time, so that the intensity count come near to 50,000. So here one I'm going to put here, so it's near to 50,000. Be remember, if it go above 60,000, the signal is going to be saturated and you are not able to get the good result. If I say I put there 9, you say the signal is saturating here. The signal is saturating here, it means you are not able to get the proper data. So please be careful that intensity will never going to be 60,000. If it is 60,000, you are not able to get the result. So for that, you have to decrease the exposure time. I have decreased here. It's coming on the range of 50,000. So once you fitted the value, exposure time, boxcar and average, after that, you just do one thing. You have to stop this light. You have to stop this light source. So for taking the dark value, the noise value. So for this, we have the three options. First option, that you going to be take this fiber out, and with the help of cap you lock it, so that whatever light source we using to illuminate the sample or reference, that will not go over there, and whatever the external light or electron noise is there, that we inform our software the noise. Instead of taking this out, with the help of this button, you make both the light off also. If you don't want to prefer this one, you can use any block, put over here, so that the light will burn to block. So here I am putting this block, suppose. So this block you can see on the software that no signal is coming, and whatever here coming here, this is the dark. So by clicking on the get background, subtract background, I have fed this value, D value. By clicking on the get background, D value is going to be saved on the buffer. When I click on the subtract background, whatever the data come, that should be I minus D or I0 minus D. So the reference is here, I have put my reference, so this will be the reference is here, I have put my reference, so this will be the I0. So I will take the shutter out. Whatever signal now I am getting on the spectrum, here, whatever I'm getting here on the spectrum, this is the I0 reference spectrum. So D is already fitted, I0 is here. So now I have to inform my software by clicking over here that this is the I0, the reference spectrum. Here I have clicked. Now after clicking this and doing this, you find here that this ABS button is enabled. Now when I click on the ABS, it means you get here the absorbance spectrum. If I uncheck this one, you get the raw spectrum. So suppose I want to do the measurement of the liquid sample that had the tap water. Now I am going to put my sample here. So you can see I am going to put on the absorbance mode. This absorbance mode. I am this water on the cuvette. And now you see in the graph that the graph that you're getting here, this is the absorbance graph. If you want to the transmittance graph, the procedure is same. Instead of clicking on the ABS, you have to click on the T. So you will get the transmission spectrum. So this is a very simple way to do the absorbance or transmittance. Only you have to take care that any value you have to not change for I0 and ID. For all these three parameters, all three parameters will be same for I0 and D. So thank you for watching the video.